Hello, this is Panda Consulting's ArcGIS workshop, and I'm Frank Conkling. And today in this workshop, we're going to go and continue our discussion about ArcGIS Pro topology, how it works, what it's doing, and we're going to explore a little bit more about the, the various ways in which you can implement topology. Before we start, a couple things. One, down in the lower right corner of our video, you will see a QR code that will go and take you to our Panic Consulting's website, which will tell you who we are, what we do, how we do it, why we do it. Panic Consulting is a a silver business partner for ESRI, and we are the first business partner in the nation to have gotten the parcel management specialty. We also have the release ready specialty and the state and local government. If you are in fact here live and you have any questions or comments, please put them in the chat window. Chris is here moderating the chat window, and we'll make sure that you get all those questions and comments introduced into here, and we take care of all those questions. So let's go ahead and start. All right. Previously, what we did at the last time we got together was we talked about topology, what topology is, how it actually works. We introduced that whole concept of the three different stages of topology, the cracking, the clustering, and the validation of the rules. We looked at the various components and how you can explore them, and we did an introduction of the rules. This time, what we're going to do is we're going to go and build on that a little bit more, and we're going to look into more details of what are the various types of rules for the different types of features that you can have inside of a topology, including we're going to explore the point rules, we're going to explore the line rules, and we're going to explore the polygon rules. And then finally, at the end of the video, we're going to look at a very interesting technique where you could take topology rules and apply them to not all features in a feature class or a layer, but you can be very specific as far as which features inside of a layer actually get applied with that topology. All right, so we're going to look at using subtypes on there. All right, so this is in fact our demo ArcGIS Pro project. And right now what we have in here is we have a topology that we had created previously. Again, this is the way it appears inside our table of contents. We have a point feature class, a line feature class, and we have a polygon feature class. Just to go over real quickly, if we go over to the topology object inside of our catalog, we can see what the name of the topology is. By the way, we can see what the cluster tolerance is, which is, as we talked about last time, is very important. It goes and analyzes all vertices or points within that cluster tolerance and treats them as if they are the same and actually pulls them together. And then it lists the feature classes which are inside your database, actually more specifically inside your featured data set, because topology is based upon all of the feature classes within a featured data set. And that's because it goes and defines one spatial reference, one resolution, and by having everything in one single definition that way, the software can go in and begin to analyze it. When you have different projections, different resolutions, it can't compare the two, but by having them in a featured data set with a single spatial reference, that's what allows it to do that. Another rule we didn't talk about with topology is that a, a layer or a feature class that participates in topology cannot participate in another topology. It can only participate in one topology at a time. All right, so we then talk about some rules that are on here, looking at the topology properties. And some of the rules, for example, we have in here a rule that says that our points must be covered by the end points of a line. Now, this is one of the changes that occurred inside of ArcGIS Pro is as we went and introduced these little graphics to help us see a little bit more what this topology rule is doing. And it's actually showing you by blinking on and off which of those points that are shown in the graphic are actually going to be marked as errors on there, which is very nice when you're first starting to learn how this works. Then we also have, in this case, we have also some align feature class, and then the rule in this case is that must not overlap. And it's going to be looking and identifying those lines that are overlapping on top of one another. They're going to appear as rules. And then we also have this rule that says that the lines must not have dangles, and it will now go and report, in fact, as shown on the graphic, those lines that don't connect up to another line. Defined as a dangle. Again, we went through that what happens with that is when you go and invoke topology and tell it to validate it, what it actually is doing is taking and analyzing all the features and treating them as if they were all on one. And wherever they intersect, it's introducing a vertex if it is not one there already. So it's cracking or putting vertices into your features. Then it's going and analyzing all of the vertices in all of the feature classes that are part of that topology and determining whether or not they are inside a little buffer around each of those vertices. And that's the cluster tolerance. And if they're within the cluster tolerance, it goes and pulls them together, and it pulls them together according to a ranking. And that's what this ranking is here, this XY ranking. And the lower the number, the more that the feature is going to be ranked higher. Kind of makes sense. It's kind of like a reverse Polish logic in some of your calculators. So if I were to go and make this one a 2, that these features would be pulled towards the ones, or more precisely, the vertices on those features would be pulled more towards the vertices on the feature classes that have a ranking of 1. Since they are all, in this case, they are all the same ranking, it actually just treats them all with the same and figures out the point in the middle of all of them. All right, so that's the cracking and the clustering. Then it goes through and looks at the rules and analyzes the rules and determines whether or not these features meet those rules or not. If they don't meet the rules, they will show up as errors. All right, let's look at some of these rules here now and see. And we'll first look at the point rules. So the point rules are kind of easy, but they're very interesting if you've ever done a lot of analysis of points. So, by the way, before we move here, I just want to go and introduce again. Esri has put out a PDF which contains all of the topology rules that are part of the current definition of topology. This is a great poster. When I was learning how to do topology, I actually printed this out on a plotter and stuck it up on the wall, and I would constantly refer to it to help me learn more, learn better. This is the QR code, so you can go and download that poster anytime in the future. I'm going to sort of zoom into some of it, and as we start talking about some of these. So the point rules. So there's actually 6 rules that specifically associated with a point. The first rule is you must coincide with. And let's see if I can go in here and start looking at some of these point rules and see if I can zoom in a little bit more, make it easier to see them. So this must coincide with. And again, this is a great graphic that shows you a couple of things. When you're reading this rule, what you want to first do is look up in the upper right corner. This upper right corner shows you and tells you what it's comparing. And in this case, it's comparing points to points. And it's saying that the points of one feature class or subtype must be coincident with the points in another feature class or subtype. And it also gives you hints as far as when to actually use this rule. In this case, when points in one feature class should be aligned with another one. And it will show you whether or not they're, in this case, overlapping or being coincident. And it says it must be coincident by this. All right, so that's the first rule in here for points. The second one, and this is what we see a lot, whether it be in parcel fabrics or whether it be in utility fabrics or utility maintenance solutions, utility networks, is that the point must be covered by the endpoint of. And again, this goes between points and lines. And basically, it's saying that the point itself has to be located not necessarily on the line, but on the end point of the line. So it's very specific on where that point must be located. And you can see in this diagram that there's points in here that are on lines, but they are not on the endpoint. So these are, in fact, errors on here. The next rule has to do with points and polygons, as you can see here, points and polygons. And it says that the points must be properly inside of it. And you can use this rule when you want the points to be completely within the boundaries of the polygons. So if you're doing an analysis and you've got a series of points and you want to find which points lie outside of a polygon, this rule, if you've gone through, will actually go and take all of those points and mark them as errors, and then you can go and determine, do I have to move them inside of a polygon, or are they in fact exceptions to the rule, or is this rule not really what I should be doing with my data here? So let's go to the next one for points. This is the points must be disjoint. All right, so again, point to point. It says, use this rule when points from one feature class or subtype should never occupy the same space. So if we look back, this one said it must occupy the same space. Must be disjoint says it should not be on the same space. This is going to look for overlapping points on here. That's what this rule is specifically for. Then we move down to another one. This is the point must be covered by a line. In this case, this is building, and it's a little bit coarser than this one here that says that the point must be on the end point of the line, because this one just says it has to be on the line. Doesn't say anything about the end point. It just says it has to be on the line, and if it's not on the line, it comes and is marked as an error. It's identified as an error on there. Again, points to lines. And then finally, for points, we have must be covered by the boundary of. And these words here, the boundary, covered by a boundary of, you'll see these again on other rules that we're looking at. Again, points to lines, and it says that you want, this is where you want the points to align with the boundaries of a polygon. Doesn't necessarily mean the line that might be on top of it, but the boundary of a polygon, where the polygon is located. And you'll see these are points that are going to be identified as errors that are outside of the boundary. They're not on the boundary of the polygon at all. All right, so let's go back here. All right, so again, 6 rules. They're fairly simplistic when you get to work on them, but they cover about everything you need to do with points. How the points relate to other things. How points relate to points. Are they on top of? Are they not on top of? And you'll see those 2 rules here up on top. How does they relate to lines? Are they on the endpoints of the line? Are they on a line at all? That's what these 2 middle rules are. And then finally, as it relates to polygons, are they properly inside? Are they completely inside, or are they on the boundary? And those that are not are just identified as errors on here. Any questions on the point topology rules? None I see.
None at this
Let,
time.
okay, so let's move forward to the line rules. A lot of line rules. So, but lines are very important. Lines, we use lines to denote different types of physical features that we might be mapping. We use lines to go and coincide with the boundaries of polygons. We use lines to connect up points depending upon what we're mapping. If we're mapping utility networks or if we're mapping parcels, we use lines for many things in here. And that's what this is for. You'll see on here, there's a rule here. This is actually in gold because it turns out, and let's go over and look at this here. It turns out that this rule actually applies to both lines and to polygons. And what this rule says is that actually it goes and applies to all lines and polygon features that participate in there. And it wants to know whether or not the points themselves are located um, larger than the tolerance in here. So vertices that fall within the cluster tolerance are defined as coincident and snap together. If you have 2 points along a line or on the boundary of a polygon that are very, 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 very close together to one another within that cluster tolerance, and if you recall, our cluster tolerance on here was 0.002. And if you have vertices that were within that cluster tolerance, what this is basically telling you is that those points are going to be considered coincident. All right. They're going to be snapped together. You're not going to be able to do anything other than saying, yes, snap them together. They are coincident. And that applies to both the lines and to polygons. All right, let's look at some more rules. These are lines. Now notice on here, it's just slightly different from the other rules in here as far as how it designates it. When you see two different things here, it means that it's between layers. All right, this is going polygons and points, but there are certain topology rules that only validate and only test those features within a single layer. And that's what this is one of these here. And this is for a line feature class. And it says that the lines themselves, you ought to identify where those endpoints of the lines do not connect to another line. This is the famous or the infamous, if we're a parcel mapper, must not have dangles. You can't have dangles on these lines because you want parcel boundaries to connect up to other parcel boundaries. You don't want just a freestanding line out there. This one's actually very useful. It's used an awful lot, and we might use it on something on some of our demos in here. The next rule for lines are must not overlap. Again, within a single feature class, and it looks to see whether or not lines are on top of one another. All right, on top of one another. Now, again, it just means, do you have duplication of line structures in there? Is it one on top of the other? There is a rule that says must not self-overlap. Where is that here? Must not self-overlap. And that's a little bit different because that what that means is that that line can't come back and go over itself. Over here, where it must not overlap, that's two different lines. Must not self-overlap means one line can't come back around and go back over itself again. So must not have dangles, must not overlap, meaning two different lines must not overlap over the same space. Must not intersect is the same thing where you've got two lines that must not intersect on here, okay? They can never cross or occupy the same space with other lines on there. That's a rule here. All right, must not intersect with. Note, we're now looking and comparing between layers in here. So this says that this lines from one feature class or subtype must not cross or overlap or in any way intersect features from another feature class or subtype. You don't want them to be on top of one another with this one. Must not over intersect or touch interior. This is one that parcel mappers use a lot in that sometimes you want to make sure that these things don't intersect. Now, what this does is when this rule comes in play and you wind up correcting for it, it actually breaks apart those lines that are touching or intersecting. This is a rule that some early data models we used to integrate because we wanted those lines to be broken anytime there was an intersection. We now have more sophisticated data models, especially for parcels, in which, for example, inside the ArcGIS parcel fabric now, we don't necessarily want that because we might have two lines, one on top of one another. On one line corresponding to one parcel, that might be the overall boundary. But on the other side, on the other line, it may represent a continuation of the property beyond the limits of that one parcel. So this rule we used to use a lot in parcel mapping, but we don't use it quite as much anymore. Matter of fact, some of the new data models don't even have it in there. Next one, must not intersect or touch interior with. And again, line to line. And this is a combination of must not intersect and must not touch interior. Again, a little bit more sophisticated as far as what it's coming with. Must not overlap with. Again, between, this is between two feature classes. And if we look up here, must not overlap, that's only within one feature class. So again, we're getting very granular in what we're looking for, but it does allow us to go and really figure out what these are and how they relate to one another. This is also a very nice tool that we don't use quite as much as we used to use. All right. Must have pseudonodes. Pseudonodes are very, very interesting. Really, what this means is that a line itself must not have a vertex without it actually breaking. In old workstation ArcInfo, when you would have a bend in a line, what we used to call a polyline, or what you can now have is a polyline, where that bend occurred, that was a vertex in the line, and these were called pseudonodes. And we used to have a command that would go and remove all the pseudonodes and break everything up, similar to what we now have intersect arcs and planarize on there. So this is basically identifying where you have vertices that cause bends that represent some sort of change in the line on here. So where you have pseudonodes, where you don't have lines. Must not self-intersect. This is what I talked about earlier, where it comes, the line goes around and comes back on itself. Again, a single feature class. Must not self-intersect. Similar, this is where the line comes all the way around and intersects with itself without being broken. Single. Must be single part. Again, this is a one feature class, so it goes and looks at all the lines inside that one feature class. And this is where you want them to be composed of a single series. You want to identify those that are multi-part lines is what it is. Multi-part lines are in fact identified as errors with this rule. So in case you, for example, you might have a linear feature such as a road in which you have the same name and maybe road starts, goes up to one intersection and then changes the name and it starts again. This rule will go and identify where you have a multi-part line and allow you to then go and fix it by either splitting it apart or exploding it using the new ArcGIS Pro terminology, exploding it or identifying that maybe it shouldn't be split apart. The next one must be covered by a feature class of, and again, this is lines to line. And in this case, this one says, show me where I don't have an overlap. This is, we went up back over here. There's one that said, show me the overlap. This is now show me where we don't have an overlap or don't have another line on top of it. That's exactly what this rule is for. And then we have must be covered by the boundary of, and in this case, this goes from lines to polygons. Once it says boundary, you can identify that really means a polygon boundary. So in this case, this is used to identify when you're comparing lines and polygons, and you're saying, show me where the line that I have is not on a boundary of a polygon. This is used inside the parcel fabric, and it's used to identify where those lines are just sort of freestanding and don't represent necessarily the boundary of a parcel. Now, inside the parcel fabric, just to sort of give you some insights if you're interested in it, inside the parcel fabric, we have a type of line called a connection line that does not participate in this topology, so that we can have freestanding lines that are not part of a boundary. And that's inside the data model for the parcel fabric. That's what connection lines are. Connection lines do not have this rule on it because they're allowed to be freestanding lines. And they can be anything from road center lines to meander lines, to all sorts of ways that you can use connection lines inside the parcel fabric. But this is the rule that says a parcel line has to be on the boundary of a parcel. Um, the next the next topology rule is lines to polygons, and it says that line must be properly inside. So there's two things that first is the inside, it meaning that the line must have vertices that are inside the polygon. But then more importantly, it says properly inside, which means that it cannot have any vertices that are outside of the boundary of that polygon. So in this case, you can see here, these two are actually properly inside, but over here you've got a line layer that is not inside, and that's identified as an error. And then also you have a line feature that is in fact whose endpoint is outside the boundary of the polygon, that is identified as an error. So in this case, you want to check for those lines that are inside. And it has a great graphic here showing that maybe you want to go and analyze lines that represent rivers inside of a river basin. And you don't want any part of that river being defined as being outside the basin. So here's where you go and use this rule. And then finally, our last line topology rule is endpoints must be covered by points. And this is lines to points. And it says basically that the endpoints of a line have to have points on the ends of them. And as you can see from this graphic here, in this case, you have a line that goes from here to here and a line that goes from here to here. When you run and validate this topology rule against these lines, it says you have a connected line here, but there is no point on the end of it. This is one of the rules inside the parcel fabric, and this is one of the more important rules inside the parcel fabric. When you do a build, it automatically goes and places points on the ends of these lines if they don't have them. In the parcel fabric, it also goes and relates those points to the active record at that time. So let's go back here now to this. Those are all of the line topology rules, and there's a lot in there. You really want to experiment if you're going to go into this and begin to sort of start exploring and figure out which of these rules do I want to test on. And that really is a good point here, is that the topology rules, you add them and you test it to see if what the spatial relationship is between the features that are in a single layer and within multiple layers, and see how they compare to one another. And you try to use that to find out whether or not it's matching the way you think your data is compared to itself and to others. It can be a very iterative process depending upon the size of your data set, or it might be something you just experiment as you're beginning to go and set up rules for your data set when you're designing it. So let's look at the last ones. These are Polygon rules. These are some of my favorite rules. And let's go back here now to over here. Here are the Polygon rules. Again, we already said there was a one rule, which is must be larger than cluster tolerance. And that has to do with the vertices that are inside of or defining the boundary of that polygon. And that applies to polygons as well as lines. So here's the first one. Must not overlap. This is one that's fairly easy to understand. And if you've got overlapping polygons within a single feature class, not between feature classes, but within a single feature class, it will identify that as an error. And then you have to decide to fix it. How am I going to handle this? Are you going to merge it into one or the other? Are you going to cut it out between the two? There's multiple ways to fix that. The next rule is must contain a point. All right, and this again, polygons to points, and it goes and says you have to at least have a point in there. It doesn't say it's only one point, but at least one point resides inside of a polygon. You want to make sure there's something in there. And the graphic shows you that you might have multiple, in this case, multiple schools inside of a school zone, but you have to have at least one point with this rule. By the way, there's a corresponding rule to it just over here. It says, this rule says it only contains one point. So if you have more than one point inside of there, it will go and mark as an error. So you can get a polygon marked as an error that it says it does not contain a point inside of here. So you'll find those that do not have any points on them. So the next rule must be covered by the feature class of it. And this is between layers, polygon to polygon, and says identify where we've got polygons that aren't covered by polygons in a different feature class. All right, should be covered by all the polygons in another feature class on there. Must not overlap with. This is where you identify between two polygon feature classes where they overlap. All right, so this one says must be covered by, and it's going to be as an error, those polygons that are outside or not covered by another feature class. This one says, let's look at the overlap between the two. This is between polygons and says the area boundary must be covered by the boundary of. This one's kind of unique in that it looks at not just a single polygon to single polygon, but looks at the overall coverage, whether or not there's an area that isn't covered by it. So in this case, the overall boundary of the polygons in one layer is going to compare it to the other. And with this, you can identify where there's certain areas of one polygon that aren't covered, as shown here. All right, let's look at the rest of these as we're going through here. Polygon must not have gaps. Again, this one's fairly easy to understand, and this is only within a single feature class, and it will identify when you have a gap or something that's not there. Now, this is interesting because we used to use this a lot in parcel mapping to try to identify where we have gaps, and those gaps the ones we were looking for, the ones between polygons. But as you can see here, one of the problems with this rule is that it identifies if there is no polygon next to it, so that road casings, road areas, road polygons, as shown on this graphic down here, we often don't map road polygons because there may not be any land interests in there, so that they always identify as an error. This rule isn't quite used as much as it used to be, and there's inside the parcel fabric, there's some new ways to identify where you have gaps within and between parcels, but not necessarily between a parcel edge and a rule or and a road. So this one's not quite as popular as it used to be years ago with parcel mappers. Contains one point. I actually showed you this before. This is between polygons and an individual point. It says, show me the polygons that don't have a point in there. Boundary must be covered by. This actually is a very interesting one. It says, identify those polygons that don't have corresponding lines in another feature class. And again, this is it within the parcel fabric, and it says, show me those lines of the parcel that I don't have a line for. And the build inside the parcel fabric will go and actually create those lines for as needed. Must be covered by, this is polygon to polygon, and it just is going to look and see where you've got areas that aren't covered by others on here. One set of polygons to be covered by some part of another single polygon in another feature class, and must cover each other when the polygons in the first one and all the polygons in the second must cover one another. So it's sort of a combination, area must be covered by the boundary of. So those are, in fact, all the rules associated with polygons inside of here. And as you can tell, I think there's 26 or 28 rules now that are in place. And you can go down rabbit holes trying to figure out which one to go and use and which ones not to use. You really just have to experiment with them to see what's happening. So let's try a little bit of it. Let's experiment with some demos. We do know that inside of this, we do have a couple of rules already in place. We have rules that say that the lines must be covered. We have points that must be covered by lines. All right. Then we have another rule that says that the lines must not overlap. We have one that the rule that says the lines must not have dangles on here. If we look at our feature classes, we've got construction polys, we got lines, we got construction points. So let's see if we can figure out another rule in here. Let's do a rule and say, let's find where our construction poly does not have a boundary on it. All right, doesn't have a corresponding line associated with it. So let's go to a new rule and let's go and add a new rule and say, let's look for the polygon where that polygon must be covered by, and this will show you area to area means polygon to polygon. This is polygon to polygon. Here's the one. Boundary must be covered by lines of the area of a polygon must be covered by a line. And in this case, we have to more than just identify that one because it's going between layers. We actually have to identify what is the line layer that goes and works with it. So we can go ahead and click OK. It's going to apply that. And after it applies, let's go ahead and first let's go and create some polygons here. All right, we know that's going to have errors with it, but let's go and create another one here in which we're snapping to a couple places. But let's put little wrinkles in there. All right, let's go ahead and save this out. Let's go and now go and validate our topology. Now remember, validate's located over on the edit toolbar. Here's where we tell it what the topology is. This is the rule-based topology. And here's our error inspector on here. And we can go and it will tell us what is the topology we're going to validate. What is the extent? In this case, you note I've got toggled down the map extent. So it only do it here. Don't do the whole database. And then I can say, go ahead and validate it. And it's going to go and give me all the errors in here. Now note, it's going to show me all of these in here. And it identified some that are outside of here. So let's look at some of these. In this case, this is a line, or excuse me, this is a point feature class, and it says it has to be covered by a line. In this case, it's not covered by a line. If we were to go and actually zoom to this here, we could right click and say zoom to, and let it zoom. And here, that point is not covered by a line at all. So that's an error on here. So let's go back here and let's go back here so we can see this. All right. So here's all our rules. Well, if I were to go and try to fix this right now, all right, and say, let's see if we can go to this fixes here. And I'll say there's no defined fix. Because in this case, you have to have a line underneath it, and it doesn't know what lines it should do or anything. We can clearly mark it as an exception, but we can also go down and say, well, let's not pay attention to that at the moment. Let's go and pay attention to things like this is a rule here that says that this polygon boundary has to be covered by a line. And if we look at the fix, it says we can create the line. In this case, let's go ahead and create the line. If we go and validate it, we will see, if we were real careful, and see two things happen. The first thing that happened was it put a line all the way around there. So just to let you know, that line was a polyline because that's our default value in here. But so it's not 3-point line, or excuse me, not 2-point lines. It's a polyline. But it does satisfy that rule. It says it's covered by a line. The polygon's now covered by a line. And then when I validated again, it went and said that corner or that point is now on that line. So it's no longer an error in here. So on there, I can say, okay, I'm safe with that. Let's look at the rest of these. These actually are still out here, and I have the ability to go in here and identify those errors here. And again, these are points, and I can identify all of those, and I have options. I can mark them all as exceptions, which means they're going to stay there. I'm not going to impact them at all, but it doesn't meet that rule. Maybe it means that the rule really shouldn't apply, especially if you get a whole lot of exceptions. Maybe you want to rethink whether that rule should be in place, or I could just go and delete and say that those weren't valid on here. Let me go and see here. Um, oh, I'll bet you that these are marked. Sorry, those are not marked as that. So let's go mark them as all as exceptions. All right. And now when I go to validate again, it says that these are all exceptions. I don't have to go and look at them. I can actually say in here, where is it? Here, I can tell whether or not I want to show exceptions. And in this case, I can say, don't show my exceptions. So it won't show them anymore. It will still, just to let you know, it will still display the exceptions, but it will not list them in my error inspector. So I have one more here. This one says that the points must be covered, or the polygon boundary must be covered by the line. And again, let's make sure that I go ahead and do this. And it says I can create that feature. I go and create it, and I can validate, and everything has now been validated with this. Very interesting. Again, once you get used to working with topology, it's really just you have to one step at a time to go through here. First in defining the rules, and then actually validating and checking to see is this really an error? Do I want to have it in there or not? So let's explore a little bit more though, because now what I want to do is I want to go and I want to include subtypes. Because if I look at subtypes, subtypes are a little bit different because a subtype is a way of defining a specific definition of a parcel type so that you have to have a list of the different types of subtypes that you have. And subtypes are used for two different things. One, it's used to identify specific subclasses within a topology. So I could say, go and apply this topology rule against this subtype in this layer, but not this one. Or it's used to identify different domains, and a domain is a drop-down list or a lookup value for it if I have specific ones in here. So I might have, for example, this might be a road feature class, and I can define different type of subtypes for the different types of roads that are in there. And then I might have what's the material that's used on those roads. And I might have one drop down for dirt roads, one for asphalt, one for concrete. So it allows you to go and build a data model, which is much more complex and takes into account many different variations in your data. But in this case, we're only going to look at the topology and what it does as it relates to topology. So I actually have over here in my catalog, I have a layer, here it is here as a matter of fact, called subtype polygon. And I'm going to turn these off, in which I have three different types of polygons. All right. And I basically had just, if I go in here and I look at my data design and go to subtypes, this is really all I did is I defined a subtype feature class, excuse me, a subtype attribute field, and that's either a short or a long integer. And then I defined it as having different types. Type number one is a parcel. Type number two is this type of parcel. Type number three is that type of parcel. It's all I did. I'm not looking at different coded value domains or anything. I'm just looking at this. So I'm going to go in here and I'm going to make an edit here. And I'm going to go and take this parcel and I'm going to go and divide it. All right. And I'm going to go and divide it a couple times in here. All right, so I'm going to now look, I'm going to save this, edits, and I'm going to look at my rules in here. Inside here, my properties. I'm going to look at first the feature classes that are part of this rule. I'm going to say, yes, these subtype polygons are now part of it. And my rules, now I'm going to start creating some rules. Now let's start with a simple rule and it says that, okay, I have type number 3 parcels. I want to make sure that type number 3 parcels have in fact, here's a subtype on here. What subtype? I want to say type number 3 are the boundary is covered by lines of this type of line. All right. So now I can look at and analyze whether or not type number 3 parcels are covered. And let me just show you it works. I'm going to first do it with type number 1 on here and say, let's go ahead and do that. Let it go and store those. I'm then going to go in here and I'm going to look at Error Inspector and I'm going to go and validate my rules inside of here. And I have dangles in here, but I have nothing on that rule that these are the points are covered by lines in here. There's dangles in here, but nothing about those subtype rules. So let's close that up again. Let's go back to the topology, look at the property and the rules, and let's go and I'll add another rule now. Now notice here, since it's already in an edit session, I can't add this. So I need to go to my catalog view, go to my properties, to my rules, and now I can go and add a new one. And I'm going to call it type number 3. And I'm going to say that the boundaries must be covered by lines. And I'm going to define the types of lines that these are to be covered by. Oh, it's being edited. Sorry. Let's go and edit that. Stop that. Let's go and add that. This is a new subtype. Type number 3 must be covered by the boundary of by the lines of here. All right, let's go in, start editing again. Let's go and look at our error inspector. And now let's go validate again and rerun it. And suddenly I see these lines having errors on them. That in fact, these subtypes for type number 3 here, subtypes for type number 3 here, do not have lines. And I can tell it, go ahead and create these lines for them, for those 3 errors in here. And create the feature. Why is it not creating a feature on here? This is what happens when you do unscripted demos. All right, let's see if I can go in here and create these features now. It won't let me do it. All right, but we've, at least on this, have been able to identify that we can apply different rules to different subtypes inside of our feature classes. Now, a subtype can, again, it can be applied against polygons, it can be applied against lines, it can be applied against different types of points. So when you start thinking about how am I going to go and build or construct my data set as I'm beginning to design what my geodatabase looks like, think about whether or not you want to have different feature classes which have multiple types of points, or whether you can combine them into a single one and subtype them. And by the way, subtypes will work across almost all types of complex structures, including parcel fabric. You can use subtypes inside of there. Gets a little strange, a little bit more complicated, but you can use subtypes inside of a parcel fabric on there. So I've been talking a whole lot. I think I'm going to stop talking and ask, are there any comments, any questions? Did we
There
learn
haven't
anything?
been any questions in the
I
chat.
see. I just,
Just a bunch of happy birthdays.
no, thank you. Thank you. All right. Well, with that, there's the demos. Any questions? We're going to go and say thank you all for being here. If you're here, stick around. Let's talk some more. All right. I'm going to stop the recording.